Welcome. In this video I'm going to show you how you can measure a parameter of interest in your fluid domain using flow simulation. Now in this specific case what I have is a combination of three set of devices. The first one is the flow divider, and the fluid enters the flow divider through this inlet, and then it gets divided into five fluid streams. At the end of each fluid stream there is a membrane device in which there is a porous media, and at the exit of each porous media device it's connected to a flow combiner, which is exactly the same as the flow divider. However, the flow direction is different, and then the flow combiner combines the fluid, and then the fluid streams exit the flow divider from here at this exit. Now I have applied the boundary condition here as the inlet flow rate and here as the outlet pressure condition. Now in our case what we want to do is we wanted to measure what the flow rate would be at the exit of each of these membrane devices. Now the question would be how you can do that. You can do so by adding a dummy body, which is similar as a lid. So what I have done is I have added a set of dummy bodies, which I have also called secondary lids, as you may be able to see in my feature manager, and I'm going to use these dummy bodies to measure the flow rate exiting through each of these devices. To add a goal related to these dummy bodies, what I'm going to do is first I'm going to go under my component control, and I'm going to make sure that these bodies are not part of my computational domain, because if it is, then it will staunch the flow and we won't have the correct results as we need. So right now, as I can see, all my dummy bodies are not part of my fluid domain, and I'm going to click OK. Now what I'm going to do is I'm going to add goals on top of this. So I'm going to right click here, say insert surface goal, and then I'm going to just quickly select one of the faces of each of these dummy bodies. Then this one here and here. And for each of these I want to measure my volumetric flow rate, and I want to create a separate goal for each of these surfaces. And I'm going to click OK here. And finally I'm going to click OK here, and that will create my goals. Now I have already added the porous media boundary conditions for these porous membranes, and I've also added the boundary condition for the static pressure as well as the inlet flow rate. Now the next what we need to do is we're just going to run this simulation. I'm going to right click here, I'm going to click run, and then run again, and that is going to run my simulation. And once that is done, it will bring up my solution window, and now it's going to go through a set of steps to finish the simulation. Alright, the goals have converged and the solver is finished. Now let's go ahead and look at the flow rate for each of these. So to do that, what I can do is I can right click on my goal plots, and I can say insert a goal plot, and here I get to choose which goal plots I would like to do. So I'm interested in the flow rates for these 5 of them, so all I need to do is just select them, and then I can either export to Excel or I can just say show here. If I click show here, then it will show me what the values for these flow rates are, and as you can see the flow rates for each of these are different, and this will further reinforce the reason why you would want to measure the flow rates for each of these line, and make sure that whether they are equally uniformly distributed or not. So in this case what I'm getting is that the flow rates are not uniformly distributed, so I have to go further and change my design of the porous media as well as perhaps the membrane devices so that the flow is equally distributed. So that will help me investigate my design further, and I will be able to make the changes and optimize the design. I hope this video helped you get a better insight into the capabilities of flow simulation and how you can apply it into your day-to-day basis designing process to optimize your design. Thank you very much. Have a good day.